Welcome to Mad Chemist, and today we will revise Chapter 1 of States of Matter according to IGCSE Chemistry syllabus. First of all, we will define the matter. Matter is made up of tiny particles which are in constant random motion. These particles basically include atom, molecule, and ion. There are three states of matter that are solid, liquid, and gas. We will discuss their properties with respect to kinetic particle theory. This theory states that every particle is always in state of motion. So, we will discuss each state of matter with respect to kinetic particle theory one by one. First of all, there comes solid. Solids have definite shape and volume. So their shape and volume cannot be changed. They have fixed shape and volume. The second property of solid is they possess low kinetic energy. The third property is they have very strong forces of attraction between their particles. As they are very close to each other and are held at their position, so they develop very strong forces of attraction between each other. The fourth property of solid is that the particles vibrate and rotate about their fixed position. So this specifies the movement of solid particles. The fifth property is about their arrangement. They cannot be compressed because the particles are very closely packed and are in orderly arrangement. Let's move to the next property, that is liquid. Liquids have indefinite shape but definite volume. Their shape is not defined but their volume can be defined. You can put water or liquid, the volume remains the same but the shape changes, just like in first picture. This is a measuring flask. Here the volume is 1 liter but the shape is changed. The second one is an open bowl. Here the volume remains 1 liter but the shape of liquid is changed. And in the third picture there is a conical flask that has different shape but acquires the same volume, that is 1 liter. Second property is they possess low kinetic energy. Their kinetic energy is more than solids but low overall, so they can't move very fastly. The third property is the particles slide past each other throughout the liquid. They can pass through one another. The fourth property is they cannot be compressed as particles are less closely packed than in solid and are in disorderly manner. This property shows their arrangement that they are closely packed but less closely as compared to solids, and the arrangement of particles is disorderly. So they also cannot be compressed because they have very small air spaces between their particles. The fifth property is they have strong forces of attraction between their particles that are less strong than solids. Let's move to the third state, that is gas. Gases have indefinite shape and volume. So as you see in the picture, the first one is gas coming out from a tap. The second one is a test tube. The third one is a beaker. And the fourth one is a conical flask. All have different shapes and different volumes. The second property is they have very weak forces of attraction between their particles. So they are less attracted to each other. The third property is the particles possess high kinetic energy. So they move very fastly, very swiftly. The fourth property is the particles move rapidly and randomly. There is no definite movement or direction of these particles. They move in a very random manner. The fifth property is they cannot be compressed as particles are far apart in a disorderly manner. So their arrangement is also disorderly and they can be compressed as compared to liquid and solids because they have large spaces between them, so they can be compressed easily. As you see in the picture, there is a syringe that is closed on one end and the pressure is applied from the other end. So as we apply the pressure, the gas particles come near to each other, and as we release the pressure, the gas particle will move at distance from each other. So this is what we discussed in our first part of the lecture, the properties of states of matter with respect to kinetic particle theory. So let's move to the second thing that is related to the states of matter and the behavior that is shown by matter is termed as diffusion. What is diffusion? Diffusion is basically the movement of particles from area of high concentration towards the area of low concentration. Particles move from high area towards the low area where these particles are less in number. For example, when we put ink in clear water, the ink droplet contain particles. These particles slowly move around and hence make the complete water looks in that specific color. First of all, there are three beakers with three different inks. If we check it after some time, all these beakers are completely changed into that specific color. The first beaker will convert into blue inked water, the second one will be purple inked water, and the third one will be pink inked water. The second example is the mixing of tea in a clear hot water. So after some time, as you put the tea bag in hot water, the clear hot water converts into brown or orange brown in color, that is the color of tea leaves or tea particles. The other thing is the rate of diffusion. The rate of diffusion is the amount of particles diffusing per second. So this determines the characteristic and property of that specific particles. So next move to the factors that affect the rate of diffusion. These factors include mass of particles and temperature. Some particles are higher in mass and some are lower in mass. So as the mass of the particle increases, the rate of diffusion decreases. Just like in our daily lives, a lean person, a thin person can run faster as compared to a fat person. A fat person has more mass as compared to a lean person. So, in the same way, some particles or some molecules have more mass and some have less mass. For example, in case of water and oxygen, water is lighter in weight as compared to oxygen. Water has the formula of H2O and oxygen has the formula of O2. So, oxygen has more mass, that is 32, and water has less mass, that is 18. So, water molecules can diffuse faster as compared to oxygen. The second factor is temperature. Temperature causes the increase in the motion of particles. So when the particles move fastly, the rate of diffusion would increases. So the increase in temperature causes increase in rate of diffusion. For example, a hot coffee has more smell around the table or around the area at which it is present as compared to a cold coffee. So the hot things or hot foods have more smell or more aroma because the particles are high in energy, so they diffuse more fastly and at distant places. So we discuss the idea of diffusion, that how it affects the rate and how it affects spread of perfumes and food smells and all these aromas. Up till now, we have discussed two main important points, kinetic particle theory and diffusion. These both terms define the property of matter and the states of matter. Let's move to the phase change, how the different phases or different states of matter change into one another with respect to temperature. First of all, there is a melting point. Melting point or melting is a procedure or a phenomena which causes the solid to convert into liquid. And the specific point or the temperature at which melting occurs is termed as melting point. So in case of water, water has a melting point of 0 Celsius. At 0 Celsius, a solid starts converting into liquid. The second phase change is freezing. Freezing is basically the opposite of melting. In this process, the liquid converts into solid. The temperature at which water starts freezing is 0 Celsius. At 0 Celsius, liquid starts converting into solid. Let's move to the next change, that is boiling. Boiling is the conversion of liquid into gas. As the temperature increases, the liquid converts into gas, and the point at which liquid starts converting into gas is termed as boiling point. In case of water, 100 Celsius is the boiling point at which water starts converting into gas, and remaining at that temperature, the whole water is converted into gaseous phase. The opposite of boiling is condensation, in which a gas converts into a liquid. So the condensation point of water is 100 Celsius, at which the liquid vapors or steam of water molecule convert into liquid. Fifth phenomena is sublimation. Sublimation is the direct conversion of solid phase into gaseous phase. There are very specific materials that show this behavior. For example, phenol or naphthalene balls shows this behavior, and at the temperature in which solid phenol convert into gaseous phenol is 80 Celsius. At 80 Celsius, the fumes of solid phenol ball can easily be detected. The opposite of sublimation is vapor deposition, in which a gas particles convert into solid directly. And in the same way, vapor deposition point of phenol is 80 Celsius, in which a gas starts converting into solid particles. So there are 6 states of phase changes that occur in 3 states of matter. Now let's move to the curves that explains these phase changes in terms of graph and heating curves. So this is the graph in which we mark temperature on one side and time on the other side. So as the temperature increases, the solid starts melting and convert into liquid. And as the temperature increases, the liquid starts boiling and convert into gaseous phase. First of all, the state remain into a solid phase. But as the 0 Celsius reaches, it starts melting and convert whole solid into liquid state. And as the temperature increases from 0 Celsius, this liquid starts absorbing all the heat and changes the particle arrangement and motion. So when the point reaches, in case of water, 100 Celsius, these particles will start change into a gaseous phase abruptly, and after a steady temperature of 100 Celsius, all the liquid convert into gaseous phase. This shows that as the temperature increases with time, solid convert into gaseous phase. The other curve is the cooling curve, that is opposite to the heating curve, in which we discuss the opposite of heating curve. Here the gas convert into solid as we decrease the temperature. So we see that as the temperature decreases from the gaseous phase, the gas particles start condensing and arranging disorderly manner, and after some time it converts into a liquid phase. And as the temperature constantly decreases, the liquid particles will start losing their kinetic energy and arrange in a more orderly manner, and hence freeze and form solid state. Each state of matter converts into another state of matter by either absorbing or releasing heat energy. This means that when a temperature increases or the energy is provided, the particles of solid in heating curve gain energy and tend to loosely attracted towards each other. Then comes a point when these are so loosely attracted that they shows the property of liquid state. Hence, liquid state is achieved. And at that point, if the temperature is constantly increasing, particles in liquid state are getting energy that increase their kinetic energy of individual particle, so they use this energy to move more violently and to break their bond with each other. When they get enough energy and they break their bonds, they shows the property of gaseous state. In the same way, in cooling curve, all these process occurred in a reverse manner. The other point is the boiling point, the melting point, the freezing point. All these points have two states of matter coexist at that specific temperature. For example, in case of water, 0 Celsius is the melting point. At 0 Celsius, solid and liquid state coexist. This means that solid and liquid both present at 0 Celsius. Below 0 Celsius, all water present in solid form, while above 0 Celsius, all water present in liquid state. Now we discuss the effect of temperature on gas particles. How gas particles are affected with the increase in temperature. When we provide temperature to gas particles, this temperature will act as energy for the particles, and hence that causes increase in kinetic energy, and this causes the particle to move fastly. As we increase the temperature, the particles will get more energy and hence move more violently. Thus, they collide with each other and also with the walls of beaker. Hence causes the particles to paste far apart with each other. So causes increase in the volume of gas. So this means that with the increase of temperature, the volume of gas increases. The next effect is the effect of pressure on gas particles. Basically, when we apply the pressure, this causes the particles to come close to each other. So if we increase the pressure, the particles will be compressed and hence they come close to each other. This will develop attractive forces between the particles. So, as the diagram tells, with the increase in pressure, the volume of gas decreases. In this lecture, we will have discussed all the important topics of chapter 1. Hope you understand all the concept, and if you want to support us, like this video and share it with your friends. Also, if you have any question or any suggestion, please write down in the comments. Thank you for watching.